So I wanted to, well, I don't really want to make this video really because I thought I would have a little bit more information, but I can go in a bit different direction, I guess, a little bit more practical on the topic of this video, which is this membrane. But I wanted to touch on the previous video where I wanted to buy this keyboard and test it because I relied on this image, and I figured, like, I did some calculation how much the keyboard portion is actually, but I'm not sure if I did like incorrect calculation, which resulted in this keyboard being slightly longer than I expected it to be. But it's very close, but I won't use it because of other stuff. But first of all, this keyboard is very good. Like, other thing is that it's very tall, but the main problem is that the back plate, or like how would I call this, is made out of plastic. So that's not great. So with that out of the way, I can throw this in trash finally. Now back to the topic of this video, which is custom membranes. And also thank you for everybody that sent me some suggestions of possible switches that I can use. I will again buy some samples, but I have been quite busy, so I did not do much stuff in this regard. But so the story is that I was writing one reply to one comment there, and I was like, wait a second, I think I could make membrane just with aluminum foil instead of like this silver-based plasticky ink that is printed on these membranes normally. And so I was like, okay, let me check my aluminum foil stock. So I found this foil, which is fairly thick, and then this foil, which is thin, but it has like this ridiculous design. And I was like, well, anyway, let's try that. And I was able to make this bond to the I guess substrate, I can call it. Which, by the way, the substrate is just laminating film. This is A5 in dimensions. So I was thinking, okay, I should try this with thinner aluminum foil. So I went to my neighbor and asked him, hey, do you have some aluminum foil? And he gave me this stuff. Like, dude, what the fuck? But anyway, so it's unfortunate that I don't have any kids because they would inherit the foil. Well, anyway, he said that he doesn't use it anyway, so he gave it to me. I think I should look for even thinner foil, but that's besides the point right now, I guess. This will be a little bit exaggerated, but basically every foil will have some wrinkles, and what you need to remove this because they would transfer onto this like substrate, like it would glue incorrectly basically, and you want this to be as flat as possible. So what you need to do basically is get something relatively soft, and you need to do this in like all directions, and basically this way you can remove any wrinkles from the aluminum foil. Then you basically get some laminating foil and split it apart, put aluminum onto it, and run this through the laminator. Obviously not this foil, it must be very, very flat, but just an example. I don't really want to do this because it's like not necessary to understand how this is done. You just run it to laminator, there's not much more to it. And the result looks something like this. This is on one side it is metal, on other side it is plastic. And so this is all nice, but you need to pattern the thing and somehow remove the metal, right? So yeah, just apply photoresist and expose it, etch it, and off you go. So okay, then you would end up with some pattern, but what you need basically is to have two metal layers, and these need to be sandwiched with one separator. And question is, how do you do that? So I was thinking that ideally you want traces on one layer and then somehow come with them to the other layer. And so I was like, why don't I fold it over? And that's what I did, and it works very well. Obviously this is aluminum, so you can do it probably once and that's it, but that's good enough. And so I have tested this with multimeter and pushed the button and it was like beep. So I was like, okay, that's good, it works. And 1 week later I returned to this with intention of making some test clicker that can press the button, so I can count how many presses would this need to disintegrate. Because there is reason why it is not done this way. The reason is aluminium, obviously, and the fact that it forms oxides, and these are non-conductive. So I was thinking that if I can do test with 4 clicks per second times 1 hour, and in 24 hours I can do 345,000 clicks, and I figured if I could get to 500,000, this would be basically sufficient replacement for normal keyboard membrane. I have doubts about it, but unless I try, I never know, I guess, because you cannot really find good data on like material testing in this regard. Maybe there are some papers, probably not. Seriously, there is a reason why people use silver instead of aluminium. So I wanted to have a look at the construction of this membrane, and they also folded here, which I never saw before, but I mean it's obvious solution, so why wouldn't you do that? One thing I kinda want to know is how thick is the separator, because in this foil it is the same thickness as the laminating film, which is not much. But also these contacts are huge, so it is easily shorted out basically. Alrighty, so here is separator. I could probably measure it directly, but let's measure it times 4, which is 0.19, 0.2. So this means that this is 50 micron foil. So what I want to do is make this a little bit more like this. There are a few difficulties, mainly with the quality of the photoresist spray. I did not care too much, but it should be good in that piece. But you can see even here, this is the defect in the photoresist. There is a track missing, and somewhere here, yeah, here it is shorted. I will probably reuse the spacing because I've already this test board set up, so I can just plug it in and see what happens there. Now it's a little bit too late, but this is also quite stiff in this configuration, but also it is bendable quite easily, so you can do this and there will be no damage really. Oh, not really, there is damage. There is already some delamination going on from the bending. So probably only bend it this way. Anyway, that's not the point. Alright, so I hope that this was not exposed to the sun for too long time. And I'm not sure which way I want this to go. Probably this way, and probably... yeah, this sounds alright. So I will probably need something soft to press on this. That will be alright. Okay, exposure is 75 seconds and let's go. Alrighty, let's see what happens. I don't want to overdo or underdo this because this is aluminum which will react with hydroxide, but if I underdo it, that will be a bunch of aluminum that I don't want there. This is fine. Okay, now I think this is hydrochloric acid, I'm not sure. It smells acidic, but I think this is azeotrope that I really stilled sometimes. Let's see what happens. I may need to go outside with this because this will be quite violent reactions once it starts. Okay, this HCl is probably more dilute than I thought it was. But it is already going crazy, so I will add a little bit of distilled water. Oh, it is going very crazy. Come on. Yeah, I'm going outside with this. This is too... Alrighty, so that went well, better than expected. So now I will remove the photoresist, which you can do with hydroxide, but I think at this point better thing would be to do it with ethanol, because I don't want to etch the aluminum at all. Acetone would work too, but you risk dissolving the glue itself on the laminating film, so I think ethanol would be way to go. Shit, don't fucking bend it too much. Anyway, so this is how it looks like. I have noticed a bit of delamination here. Not sure what that is about. It's possible that the ethanol did not do very well to this thing, because I think that the glue here is the same thing as the hot melt glue basically, and that does not like alcohol too much. So yeah, maybe the hydroxide would be better solvent for the photoresist. Anyway, next time I can test that. Well, maybe, if there will be next time. Now it's time to make the separator and bend it over this line basically. This is the template I have made for separator. The holes are bigger than the contacts here, and this is copied from that keyboard. This is 4mm, this is 2mm, so we'll see how that goes. And this is the separator. I have basically glued the film here and used tool like this to basically cut the holes. It's the best I could come up with at the very short notice, I guess. However, I have realized a little problem there will be. Basically, the reason why I originally have made so big contacts is because this will be laminated onto like itself, and so if there is exposed glue, it will likely be glued together. So I will have to come up with some alternative method of laminating this. Basically, I cannot use rollers. I have to use like iron to do that. But even before that, I need to cut this separator. It's fairly easy. It does not need to be exact. Oh shit. Like that. We'll cut a little bit close to here. And I need some exposed contact, so I will cut it here. And so here it is. Okay, so to make my life a little bit easier, I will align this a little bit and we'll try to connect these with soldering iron. If this will hold, I have no idea, but yeah, I think it will hold there. Okay, now I can bend this, and I have this bunch of vias that are printed. This is bend line basically. Looks good. I should not really bend this too often, so now I will just grab something hot and press on the thing, and hopefully this will work. So that worked. It does not look very great, but I'm fine with that. Question is, does it work? So this Arduino is set up that it just flashes red when I press the button, and for some reason this one column has stopped working. I have no idea why. This one is missing pin here because I dropped it and I'm not disassembling another USB connector just to make it work. But it works. It does not like to be bent for whatever reason. This button worked too excessively, I guess, because if I pressed right here, it lit the LED on, even here. So could be that this is somehow bent, and maybe I need to use a little bit smaller separators here. But otherwise, it works quite great. The force needed to actuate this is very small, like it's just the weight of this pen. And I can measure how much it weighs. It weighs about 7 grams, so that's what needed to actuate this one. And I'm thinking, how am I going to set this up for testing, because first of all I'm not sure if I want to use 12 volts for this relay. Well, let me do this. And I need to put that relay somehow on there, and it does not really fit, so I will just cut this a little tiny bit. Yeah, that's much better. So now I can put this here and press the relay and it will work. But I want this to be I want this to be level. So I will probably need to find some support for this, so it sits here. Anyway. Alright, so guess what? This was super easy, just 2 dabs of hot melt glue, but as I was writing the code, which is super simple for counting the numbers of button presses, you can see that the LED is stuck always on. So I can say that this took like 100 button presses until the thing broke down. So yeah, this may be not the way to go, really. I can try to cut this button off and move on to this one, so we'll see. This works. However, I have a feeling that as soon as I start this thing, this will start reporting problems. Alright, so I have removed one more button, and now it shows value of 1, and if I press the button, it shows value of 0, which is as it should be. And I've done 3000 of these. So I guess let me restart this and we'll see what happens. I'm expecting like 100 maybe or something like that, but let's see. Alright, the first click it did, it got stuck on 0, so this must be too much force, but I have done this by hand, and I have used quite a lot of force and this did not happen, so what the fuck? And there is also no visible mark on this button, like that it would be damaged or anything, so I have no idea what this means. This is weird. Alrighty, so I have discovered that if I bang on the thing, it will fail permanently, which is not great, but it's probably something I can work with. Okay, this is now just ridiculous. I have added a little piece here just to protect the key, because I have found out that when this is actuated by the relay itself, it will permanently stick the key together. So I have removed a bunch of keys, and I will see if this will work. But oh yeah, now it works. Now it counts. Okay, let me reset this. So the force of relay was too much, but here you can see if these numbers match, the thing is working correctly. Basically every key count is registered correctly. And so yeah, now I can let it run for a while. Okay, so now I was able to do 2500 clicks, and this time the button is stuck open instead of stuck closed. Now I think somehow this this fault broke. I think. I'm not sure. But yeah, this is fucked up completely. Okay, so it's time for a conclusion. This works, however, not very super well, I would say. Basically, if you use too much force, you can get this contact stuck. Somehow, when I was testing the last working button, somehow, probably, maybe this broke in this fault. Maybe there's another problem, who knows. Basically, it stopped counting when I was pressing the button, and that's it. I counted 2500 clicks, which is not enough. However, on the other button I counted like 3000 something, and it was still working fine. So who knows, it could be just all the manipulation with this broke it basically, but that's not good. Maybe this will work better with copper, however aluminum is much more available, cheaper, like easy to work with, so overall I think this will take quite a lot of research to produce membrane that is working reliably, and I don't want to do that. This is just proof of concept, basically a presentation of how easy this is to construct and how nice it can be, and that's about it probably. So yeah, see ya next time. I have late news from the editing desk. I have watched a video from this agenometry guy. He has quite interesting videos, and I watched this one and I was like, that looks like a very usable keyboard. And so I bought the thing. The keyboard is quite shorter than I could fit on the computer I want, but I was like, okay, I want to at least touch this, because it looks relatively cute actually, and it is shit. And I don't know, maybe it's the problem of this device in particular, but it is not very tactile, it is quite mushy, and you can see that the key is hinged on the bottom, which is quite interesting, and I would like to see how they done it. But because the key is hinged on the bottom, basically it feels very weird when you type like this. If you would type like this, it feels much more usable, I would say. But this way, because you press this way and it is hinged there, so it's bad. But the thing is, this is silicone dome keyboard with carbon contacts, and so I wanted to see how they done the things they did. So unfortunately this seems to be fairly difficult. I mean, first of all, this silicone is ultra fragile, like I already broke it, I think, somewhere here. Then second of all, the way they do the hinge effect is they basically glue the key there. Let me make better focus a little bit. Yeah, so you can see how this is glued on there, and yeah, how this silicone is fragile. I hope that I would be able to just like press it on and it would hold there. Like, it holds there a little bit, but like now I can remove it just like that, and that is not great.